All right, welcome back to Introduction to Programming. This is part two of our sorting algorithm. So we're going to continue on with the straight selection sort, and then we'll do a code side by side with the algorithm itself so that you understand what's going on. So like I said, we're going to start with an integer array. Okay, now again, this is bad practice. I'm just doing it because I don't want to be writing out std out. I'm just trying to teach you the algorithm, but please do not do this after this class. You should always do std : with the resolution operator and not using namespace std because of conflicts. Okay? Okay, so here we're going to declare an integer array. We'll just call this sort me. Okay? And then I'm just going to declare a size of 5 as we did. And then we're going to actually initialize the values here. So I believe that the values that we had were 17, 53, 2, 7, and 29. Okay. So I'm going to write out the steps of what we wrote before. And I'll comment it over here. The first step is we need to establish the lowest index of the unsorted array. And then the next step is we need to find the lowest value in the unsorted array. Okay, and then the last step is we swap 1 and then 2, right? And well, we can do this the following. We can do that. We'll do the other way around, right? And when I say 1 and 2, I'm just looking at the directions, right? So this would represent number 1, and this would represent number 2 here. Okay, so the first thing is we gotta establish the lowest index of the unsorted array. Now, with sorting algorithms, we have to do nested loops. You can't get around nested loops, which means that the initial outer loop is going to start at 0. Okay, so we're gonna say for int I is equal to 0, I is less than size I plus plus. Okay, so this outer loop is actually going to control my index of where my unsorted array begins. So if you see a pattern here is, as we start at 0, okay, that means that my inner loop, okay, is going to do the following, which is step 2. Which means that I can say for int j is equal to, well, what is the lowest index of the unsorted array? So the lowest index of the unsorted array is 0 initially, right? Which really is I, because as we go through the next iteration, I will become 1, and then remember, we move up the wall, so that means that j is I, right? So j is I. We are going to go up to size, and that is really no problem. Okay, so now knowing that our establishing the lowest index is actually going to be your I every time, because remember, this inner loop is going to go through all the way up to size. And as this traverses up to size, I stays at 0. So think of I as your wall, okay? Wall. Okay, and then this inner loop is a representation number 2, finding the lowest. Okay. Now, how do we identify which one's the lowest? Well, we can do the following. We can say that, remember I told you that we don't know, the computer doesn't know any better, right? Even though when we look at the drawing on the last video, we saw that we found the lowest array looking up from up top, but the computer doesn't know it. So what we can do is we can give it a default value. In this case, I'm going to say that my lowest val is going to be sort me of I, right? And that's going to take care of every time that my wall moves up, right? Because on the first iteration, my wall starts at 0. Then on the next iteration, my wall starts at 1 because 0 is going to be my sorted part, and then everything to the right of that is going to be my unsorted part. Which means that as I go through my wall, then my lowest index is going to be really my lowest value, right? And then we can, I'm going to declare these up here. So int lowest val, okay? And we're just going to have a lowest val index, okay? And then my lowest val index is going to be I. Okay, you'll see why in a second. Okay, now here's where we find the lowest value. And as we saw from previous videos, and if you haven't, please go back to my videos on finding the min and the max. I have them on this playlist. We can say that if my sort me of j is less than lowest val, then lowest val is equal to sort me of j. And then my lowest val index is going to be j, right? So again, this is finding the lowest, and as we go through each element using j as the iterator, we are going to compare it to the lowest val. What's my lowest val initially start out as whatever we are at the unsorted array. So if you picture this in terms of starting at the initial time that we start iterating through the array, we know that I is 0, so 17 currently is my lowest value. We're going to end up, after we go through this initial loop, right, it's going to find that 2 is going to be your lowest value, and then your lowest index is going to be 2 as well. So 0, 1, 2. I didn't do that on purpose, but okay. Just so you know, we can do the following. So this is 0. This is 1. And this is 2. And this is 3. And this is 4. Okay, just so you have a point of where you want to identify. Okay, after this loop, really the only thing we've done is finding the lowest value, but we haven't done any type of swapping. So now after we break out, okay, the swapping now starts. So the swapping should only happen after I'm done with my inner loop, because I have to get out of this loop with the lowest value. I have to, okay? Whether it be when I start at 0, it's going to be this one, and then when I move up, then it's going to be 7, and so on, okay? So now, after this loop, I'm going to swap, okay? Which means that if we look at, just for all intents and purposes, we know that we need to swap this with this, right, on the first iteration. Now, obviously, I'm not going to do the hard coding of element 2. I actually want to use what I have, okay, I'm also going to declare, so with swapping, as you saw in my previous video, we want to use a temp. Okay, so my temp variable is going to be sort me of what's my lowest index. Well, my lowest index is I, right? Because even though we broke out of this loop, we know that I is still 0 because we haven't gone back up. Okay, and any time we move the wall up, I is going to move up. So think of I as your wall. Okay, now we're going to save the lowest index in temp because we want to write this one over. So now I can say that sort me of I is equal to sort me of lowest val index, because that's where we found the lowest value. Okay, so we're overwriting sort me of I, so we're overwriting the lowest index. Okay, I'll make a note here, overwriting lowest index. Okay, and then here what we'll do is we gotta swap back the element that was in the lowest index, okay, and put that put that on temp. Okay, we can't do sort me of I because we already rewrote it, right? We overwrote it. So once we did line 28, that's it. Sort me of I is gone. So whatever value was in sort me of I is gone. So if we're looking at this at the first iteration where I is 0, 17 will be gone on line 28, but we made a copy of it, right? We used temp to make a copy of that 17, and then we place it back to the lowest val index, which is element 2. Okay, and that's it. That's pretty much it, and we're done. Now this is going to iterate through, and by the time I get out of the outer loop, I should have a sorted array. So let's take a look. So if I say int I is equal to 0, I is less than size, I plus plus, and then we can just say cout sort me of I, and then do end line. Okay, so let's take this for a spin. And then you see that my array is now sorted. So 2, 7, 17, 9, 53. I should write it before sort. So I'm going to do the following. I'm just going to do the following here. And then just say before sort. And then we'll do cout after sort. Okay, so let's do that. Okay, so here is before the sort, and then we see after the sort. Okay, so on the next video, I want to show you how this looks in terms of the drawings that we initially did on the first video before this, and we'll put everything together as in a circle, right? Kind of like a circle of life. You ever heard of that Elton John song? It's a circle of life. Okay, okay, sorry, bad joke. But we will put this all in full circle, and hopefully you can connect the dots back to the drawing. Okay. And I promise the next video will be a little shorter. It'll be about 5 to 7 minutes. I'm not promising. Actually, let me not promise that because it may be a little longer. Okay. I'll see you on the next video.